Hi, I'm Jen O'Brien. I work with Hawks Learning, and today's webinar is going to focus on the topic of accessibility. I'll start off by talking about what it technically means to be accessible in terms of adhering to the law. And after that, I'll go into more detail about the specific approach Hawks Learning is taking to make our materials more accessible. And I'll jump into the software to show you some specific examples of that as well. So legally and technically, what does it mean to make materials that are accessible? To start, the Americans with Disabilities Act prohibits discrimination against people with disabilities in employment, transportation, public accommodations, and a variety of other areas. Section 508 specifically covers electronic communications. So Section 508 is a law that Hawks Learning and any other publisher or content provider must adhere to. In order for us to know if we're meeting the laws set in Section 508, we can refer to something called the Web Content Accessibility Guidelines, or WCAG. Now, within these guidelines, there are different levels of compliance, and in order for us to meet everything that's outlined in Section 508, we have to be WCAG 2.0 level AA compliant. So in terms of where we stand with our materials, our instructional content and question bank do meet the WCAG 2.0 level AA compliance standards. Additionally, our goal is to ensure that 100% of our questions are compliant for every one of our titles. In other words, we don't want to have to flag some questions as inaccessible that therefore have to be removed from the course in order to have accessible materials. And in fact, we've already reached that goal of making 100% of our question bank accessible for the majority of our titles. If you're curious about any specific titles, you can talk to your Hawks representative to get more specific information about the status of a particular course that you're interested in or using. Now, meeting this standard does mean that we're adhering to the law, but it does not necessarily imply ease of use. And it's really important to us as a company that we're doing our best to not just provide accessible materials meeting this minimum requirement outlined by law, but we want to make sure we're doing our best to make materials easy for students to use, allowing them to focus on the content they need to learn and not how to navigate a system. So to show you some specifics, I'll jump into some examples of how we've met and in some places exceeded these accessibility standards in our software. We have closed captioning for all videos in the software. You'll find this option available in the bottom right-hand corner of all lesson level and example level videos. This is important for students with degrees of hearing loss ranging from mild to profound who might need all audio content supplemented with text. That being said, it's also helpful for students who might just find it easier to follow along with the content if they're watching and listening to the video, but also reading what's being said on the screen as well. For students with low vision, they need to be able to magnify or zoom in on the content. So for our math titles, we use HTML5 and provide math-specific magnification. This will allow the student to zoom in specifically on math expressions, enlarging just the expression, while everything else on the screen stays the same size. And as you can see on the screenshot, students actually get to select what will trigger the magnification. They can choose to zoom by hovering over the expression, by clicking on the expression, or double clicking. Alternatively, of course, in any product, students do have the option to zoom just by using the browser magnification zoom option as well. Another topic regarding magnification is that we use scalable vector graphics, or SVGs, for graphs, maps, and diagrams in our software. And one of the benefits of using SVGs is that they allow for students to zoom and scale all of our graphs and mathematical diagrams without them becoming pixelated. So meaning, as you can see on the left-hand side, we can zoom in on this image and it remains clear and sharp rather than looking blurry, as you can see on the right-hand side of the screen. And there's actually at least one other benefit to using SVGs compared to other image types, which I'll share a little later on in the presentation. Regarding visual disabilities, another important consideration is for students who are colorblind. For these students, it's really important to make sure that no information on the website is being displayed solely in color. So for instance, we can't have a graphing question where there's a red line and a blue line, and then the instructions reference the lines by color. Because if that were the case, some students would not be able to make that differentiation, would not be able to determine between the two lines based just on color. They would need to be labeled. And you can even test this out on any website. So if you're curious to see, are you losing information by removing color? There's a free high contrast Chrome app that you can install to a Chrome browser, and it would allow you to display any website in grayscale. This screenshot is an example of showing Hawks Learning in grayscale. So of course you no longer see the color. We do have different colors for Learn, Practice, and Certify. But even though we color them differently, when the website is displaying fully in color, you're still not losing information when it's removed, because each of those three modes is still very clearly labeled as Learn, Practice, and Certify. To adhere to accessibility standards, another thing you have to pay attention to is making sure a website is easy to navigate. Now, intuitively, this is useful for all of your students. Making a platform easier to navigate and removing inconsistencies will shorten that learning curve and let your students focus on just learning the content. However, students with cognitive disabilities that can relate to memory, attention, problem solving, verbal or visual comprehension, it becomes imperative. So for instance, a website can't have or shouldn't have buttons with ambiguous names such as click here. They should instead be very clearly labeled, any button, and navigation and context needs to remain consistent from screen to screen or page to page. We made some intentional changes to our platform in order to make it more accessible and usable. So to give you another example of what inconsistent and unclear navigation could look like, if we had a submit button on a homework assignment, which submits just the answer for a single homework question, but then we had a submit button again, but this time in an online test environment, that submit button submits the entire test, that would mean that the button isn't clearly named. Submit would function differently in homework versus the online tests, and therefore the navigation and context would be inconsistent. As you can see in Hawks, to avoid this type of confusion, the button says submit answer, you see in the bottom left-hand side of the screen here, in our practice and certify modes, because it is just submitting the one answer at a time. However, in web tests, you can see the screenshot on the right side of the page, we instead have a submit assignment button, which turns in the entire test. So in Hawks, you'll find that the font and colors really are maintained in a consistent fashion from lesson to lesson or page to page. Again, for websites to meet accessibility standards, students have to be able to navigate the entire website using only the keyboard. This is because students with mobility or dexterity impairments might not be able to use a mouse. Therefore, they do have to be able to access everything with just a few keystrokes, the tab, space, arrow keys, and the enter button. Additionally, students who are blind will need to be able to navigate the website using not only just the keyboard, but also a screen reader. Now, in order for us to assist with keyboard and screen reader navigation, we've created a screen reader compatibility mode that students can very easily turn on under their settings that changes the default location of the focus indicator on each page in order to better support students who are using a screen reader. Along the same lines, a screen reader doesn't only read the content that we see on the screen, they're also completely reliant on the coding that's used on the website. So there needs to be consistency and it needs to be simplified when possible in order to make it easier for students to understand clearly what's being read out loud to them by a screen reader. So a website can be technically compliant with accessibility standards, meaning a screen reader technically works with the website, but still be functionally inaccessible if the code is structured poorly. And to work towards this higher standard, we really, our goal was we wanted to use this properly structured HTML and MathML coding throughout the entire website. And I want to show you more specifically what that means. If you take a look on the screen, the math on the left-hand side and the right-hand side looks the same. However, the coding structure is very different between those two. And if you see in red, we're displaying what that coding structure actually is. And what we worked on is making sure we were removing any extraneous information. So on the left-hand side, you see it says start layout, first row, first column, rather than just directly moving into the math, which is what the more concise right-hand side shows you. This again highlights that just because something is accessible does not necessarily mean it's easy for a student to use it. And it's our job as a company to make sure we're doing everything we can to properly structure our code so that students can better understand what's being read to them if they are having to use a screen reader. In order for screen readers to be able to explain an image to a user, there has to be alternative or alt text programmed into that image. So any graph, map, or diagram needs to have clear and concise alternative text for images that also simultaneously don't give away the answer, right? We need to describe it without giving anything away if it is in an actual question. And earlier I mentioned that we use scalable vector graphics because the images are scalable, students can zoom in. But we also, the other benefit to using SVGs is because other image formats such as PNG or JPEG have significant restrictions on how many characters of alt text can be read by the screen reader. SVGs don't share that same limitation, and that's really helpful for scenarios where, for instance, if we have to explain a really complicated graph or image without giving away an answer or sharing information we're not supposed to be sharing. To combine a couple of topics that we've already covered today, even our graphing questions in Hawks can be read and answered using only a screen reader and keyboard navigation. And as I mentioned at the beginning of this presentation, we really don't plan to flag any questions as inaccessible in the long term. We're wanting 100% of the content to be accessible, so you can assign any question to all of your students. For instance, even all of our graphing questions in college algebra are screen reader and keyboard navigation compatible. In fact, every single question in the college algebra title reaches those standards. But I'm going to show you just a quick example of an easy graphing question in our developmental math title using only my keyboard and a screen reader so that you can see how it works. And for demonstration purposes, I'll just be using the free Chromebox screen reader extension. So let me go ahead and open that now and pull up our software. I have the graphing question pulled up here. I will turn on the Chromebox, and that way, hopefully you'll be able to hear this reading out loud as well. Let me make sure I have my volume up for you. And I will then navigate back to this page. Oh, there we go. So it's turned on there. So to start, I'm going to click Tab. That will put the cursor on the origin. I press the space bar in order to draw a dot. And I will then use my arrow keys to move that dot into the correct location.
A dot drawn 4 units left of the origin. A dot drawn 4 units left of and 3 units below the origin.
I'll then press spacebar to plot the point. I'll click Tab again to go back to the origin.
Point B.
Spacebar to draw the point.
A dot drawn at the origin.
And then my arrow keys to move it.
A dot drawn 2 units right of and 1 unit below the origin.
Again, the spacebar to plot the point. Tab
Exited application image.
to submit answer.
Submit answer.
And I click enter.
A dot drawn 4 units left of and 3 units below the origin.
And there I was able to graph completely using just my keyboard and the screen reader as well. So wrapping up here, I'll go ahead and Share my screen one more time. We are working our hardest to make sure that our content adheres to the law, Section 508 of the Americans with Disabilities Act, by reaching those WCAG 2.0 level AA standards. But we're also always doing our best to take it a step further than that minimum compliance to make sure our materials are user-friendly and intuitive for all learners, whether they're reliant on screen readers or not. And of course, as with anything relating to technology, things can be ever changing. So for up-to-date information, or if you have any extra questions and need more information at all, you can contact your Hawks Learning representatives. We're happy to work closely with schools on this issue. We're always striving to further improve. And so therefore we welcome feedback and any comments that you might have. So thank you so much for your time today. I appreciate it.